sort of CAD program, like AutoCAD or something similar, you'll draw up the object that you want to make. So you can use different colored lines to get the laser to do different things. So I have these set all for different reasons. The different colors will sort of be assigned a different value. So when you're done sort of setting that all up, you bring it into your laser cutting software. You adjust all the numbers so you can tell the laser to move the head faster or slower depending on how much heat it's going to take to burn through your material. So really thin material like paper, you want to go really fast, or you're using a thick piece like a 1/4 inch piece of plywood or something like that. It's got to go pretty slow to burn its way all the way through. You can also set the laser purposefully not to cut through, and that way it'll just kind of do like a scribe line into something, so it'll give a little detail without going right into it. It also does have engrave functions where it moves back and forth just like a printer head, and fires on and off where there's black and white, and basically can do sort of engrave a pattern or an image. You can take a picture of somebody's face, balanced it properly in black and white. You can engrave that image. You can put it on a piece of wood or something like that.
Could you do like pens and all that kind of stuff?
Oh yeah, it works on pens.
Kind of stuff, yeah, or use like technology. I think I've seen these kind of things work with like take an iPad, you want to like scribe your name on the back of it.
Yeah, totally. Yeah, it can exactly do that stuff. Yep. I use it mostly for making architectural model parts. So I haven't ventured a lot into sort of the custom laser cutting. I do it when people ask and stuff, but I never really got into advertising it because it's sort of another thing outside of the business that I'm used to and know. So it was it's something I don't mind doing, but I didn't want to be flooded with that kind of stuff while I'm in the middle of trying to finish a massive condo modeling that's 6 weeks of endless labor. So you kind of got to balance these things out. But anyway. So you load your file, it just connects by USB right to the machine. And you just open it up, you lay your material right down here. You can see there's a little red dot pointer that shows you where the head is. That's not the laser beam, the laser is actually invisible. This one has a neat device where I can get it to outline where it's going to cut. And it'll show me just to make sure you've got material underneath everywhere you want to work, and to help you, center your piece or whatever you need to do. So when that's done, just close the lid down. Flip that switch for me. Yep, that's it. Yep. That'll turn on the air compressor, which blows a little bit of cool air out of the nozzle. It puts out flames and that sort of stuff, and it also keeps the material cool so it doesn't melt too much. There's also an extractor fan that kind of takes the smoke away. And you just hit the start button, and away it goes. So it's going to do the red lines first, as I told it to, and it's just doing a scribe. So it's just lightly going past with very low power, just enough to burn a little crease in the paper. So you got to really be very careful when you set it, because it's easy to go right through paper. Right?
Not really, yeah. It's still early, yeah. So.
Once the signs start to go up, it's a full-time job to manage the signs. Keep them up.
Up there, take it, whatever.
A lot of times we get something big. You can start in earnest, probably what's not that's well.
There's a lot of different ones. You get small ones that kind of top size. That's this one, I did with everything. I bought it about 5 years ago with everything all together. I think it was about 10. Is it really good? Yeah. There's some that are similar that are around 30. Mostly Japanese parts. It does give me a headache. The software manual is really terrible, But I didn't really use it. Yeah, I didn't want to pay $20,000. Still have some manual.
Trial and error.
Yeah. It's starting to cut now. It's still describing.
So usually you will spell paper and
Most of my stuff's done out of plastic sheets, so that sort of stuff like big sheets of 1/8, 1/16, 30-second acrylic. Plus got lots of scraps and stuff here, so we kind of find some little pieces of this and that. And most of the models are made of this. They last longer, they're stronger. You get more detail, it's not just for here. So paper I just do for quick kind of light stuff, that kind of thing.
You have to teach them for a job though, right? You go back.
That's right. No, you can take them home, and they're from the Railway Museum. It's a copy of Nolan's Station, Nolan's flag station, which is a little flag station people used to wait at the train. They'd stick a felt to make. Furniture, weird construction. Sometimes they'll do this is a whole building. This is here. This is it's a work in progress right now. But this is a copy of that wall there, right? It's laser cut in clear plastic. You can set that. Yeah, so it scribes a brick pattern on it. You can, in AutoCAD, it's really easy. It's just like a fill button. You click the brick here, it fills the whole space with it. It's pretty awesome. Getting it the right size and the right place is tricky, but that's the details of work. But all these little pieces are all laser cut and glued together and assembled in the balconies. It gets sanded and then painted different colors, whatever you need to reproduce. So, we'll get samples from the actual clients about this is the concrete we're using, these are the bricks that we're using. This is an imaginary building just for an example, but the other ones they're very, very precise to show as accurately as possible. The architect's idea and what cones and all this kind of stuff. You draw it all up. You create a certain file type, you send that file type to the machine, which has a computer inside it. It takes that file type and it breaks it down into layers. So each layer is only about the thickness of about a piece of paper, a thin piece of paper, 0.003 of an inch, right? So really, really thin. And so it'll make 1,000, 2,000 little layers of your object, going layer by layer by layer by layer by layer, and it'll create a silhouette of what that object looks like for each layer. So what then happens is, when it goes to build the object, you hook up a little pad that goes in here. You sort of saw the pads there in the workshop with things stuck on them. They attach to the bottom of this device. And then this is the cartridge here that holds a UV curable fluid. So it's like a sticky, resiny kind of, smelly kind of plasticky stuff. It slides out on a film. It's got a little pump and everything here, and an arm comes out and draws out a layer of film with the goo on it. This gets lowered down so that it's just touching the goo, and then a light bulb comes on and displays the image of the silhouette of the first layer. And the UV light hits the fluid and converts it relatively quickly into a solid from its fluid state. It cures it basically right on the spot, stuck to the pad. So then it lifts up a little bit, it redraws a fresh screen, so a new layer of fluid, and then sets down again, but this time just one layer higher. And then it cures the next layer with the next pattern, and then it lifts up and redraws another one, does another one, and does another one, and slowly builds object layer by layer by layer by layer by layer. So it doesn't matter how complicated the object is. You can build stuff that's hollow inside. You can build things that twist and turn. You can build stuff that you wouldn't even be able to cast because it can do things inside out in a way, because it does the whole layer at once, right? It can connect stuff that you couldn't otherwise connect. You can have open loops and objects that turn in on themselves and all sorts of things that you wouldn't be able to do. And then when it's all done, it'll be sort of stuck under the pad here like this. You take it down, there's sort of a little washing station here with sort of a solvent that just gets the leftover goo that's just sort of sticky and takes that off. And you just rinse it with a little bit of water after that. There's a little UV curable bake oven in there, and so when it's all, once you've got it cleaned off, you just stick it down there, run it in there for maybe an hour, or alternatively, you can just leave it in the sunlight for an hour or two. There's a lot of UV light for free coming out of that. Got to be a sunny day though, and not nighttime. And so that just gives it a nice final hard curing, because when it comes out, it's still a little bit flexible, a little bit bendy, so that'll give it a nice firm final sort of curing, make it nice and hard. So then when it's done too, like the material, you can sand it, you can paint it, you can shape it, you can drill into it. You know, you be careful, but you can do it. Just a second, Freddie.
Can I see that machine though?
Yes, you've seen that machine many times, buddy.
Oh,
Yeah.
I can't see
But
inside
that's the
it.
basics of how it works, and it just you know, like it can make anything as complicated as you can come up with. And the way this particular 3D printer works, because it cures everything a whole layer at a time, the amount of time it takes to build your object is solely based on how tall it is. So if you just had a pencil and had it like that, it would take a really long time to just make that one pencil. But if you had sort of a flat object that was maybe even 10 times the size, it would only take as long as the highest layer. So
you're constrained, the height of what you make it, you're constrained by the size of the printer.
that's right, yeah. So you've got sort of, these are the pads here.
But you can make it in pieces and assemble it afterwards, right?
That's right, exactly, yeah. So you can do multiple stuff, and sometimes that's a good idea too, because what the computer will do is it will build supports. It will decide where it's going to put these supports so that your object doesn't fall off the pad while it's being constructed. And so you have to go back and snip off these little supports. Other systems have ones that are soluble. You just leave it and they would dissolve the supports, or you melt them off or something like that. There's different kinds. But these ones you actually have to sort of snip it and sand it and file it down. A little bit of extra work, but sometimes you want to build an object too so that you limit the number of supports on it. So you might make something out of a couple of pieces so that you don't have to do a lot of clipping and sanding and that kind of stuff. Save yourself a little bit of work later. But only experience helps you with that. The first ones didn't always turn out so well. I still have problems with it. They're not perfect machines, and they do the issues with this one. Like it does occasionally. I have problems with the cartridges where they will fail. The cartridges themselves, like the fluid won't pump properly, or something of that along those lines. I've also had stuff too where a piece will fall off and then it'll get sucked back in, and then it'll clog the drain, and then the goo gets everywhere, and then you're cleaning it up. And so like any other machine, it has its you're ready to throw it at the window some days. If it wasn't 150 pounds, I think I might have already.
Does it have to be level to work?
It really helps, yeah. You want to keep it roughly level, so I did that at first to kind of balance it, and it's got little adjustable feet to kind of set it up.
Is it a lot of cleanup when you're done?
No, it's not
really.
much. Like it's sticky and gooey, and so you just kind of dump it in this thing here. It's just got some just a little solvent that just dissolves the extra residue of goo off. You just run it in there for about 5 minutes, take it out, rinse it with water.
But
it's ready
nothing
to
ends
go.
up on that glass plate or anything? Is it
Oh,
building on
sometimes. Sometimes a little bit will fall off and get stuck
But
there.
that's it?
And you got to kind of wipe it off a little bit and clean it off. It's good to keep it nice and clean too, because if it's dusty, that'll interfere with the light, and so it won't cure as well sometimes if it's dirty. So you got to watch for that. So yeah, it helps to keep it clean and dust free. So that's why it's in here. It's not as the workshop. It's very tidy right now, but it normally is a lot dustier than that. I sort of tidied up for everybody's benefit. But normally, you put your hand down, you're like, ooh, it's sawdust or paint dust or something on you. So if that got into this machine, that would be very, very good.
Daddy, does the Google?
That's how it works, yeah.
Oh,
Freddie. Fred.
So if you wanted to do something that had gear, like moving gears inside,
Yeah.
you can do that as long as
You can, yeah.
it's
The different.
designed well enough?
Yeah, there's you have to leave a certain amount of tolerance space between your objects
Right.
of non-contact. It depends on this one. I'd have to look up exactly what that space would have to be for this particular machine, because I haven't worked with too many interior working parts. But you sometimes can do that. You can actually have moving parts built inside the object. It's a little trickier this one because it builds those supports. So you have to remember that those supports are going to be somewhere.
So otherwise you would design something that was like a piece and a piece and a piece and then assemble it later if you wanted
That's
to.
usually easier.
Okay.
Despite it taking a longer time, it's usually easier to do it that way and then assemble it. But I find this one's a very good machine, like for its cost and its speed, for the accuracy that it produces. A lot better than those kinds that extrude the plastic, like hot plastic out and kind of squeeze it out. This one it's sort of more of a more accurate type of printer, but I still find that I did some gears for a friend of mine, and the tolerance in the gears is kind of, you'd actually get, if I laser cut the gears, they'd be more precise, so, and cheaper and faster, so,
Yeah.
so sometimes you gotta use the right tool for the right job, but, yeah, we were sort of experimenting at that point, trying something new. Yeah, sometimes I'd like to upgrade to a more powerful 3D printer that does some more stuff, but some of those are very expensive. So there's a whole slew of inexpensive ones though coming out now. There's some sort of in Kickstarter campaigns and that kind of stuff. There's a nice one, looks pretty good. It would probably produce similar quality to this one for only, I think it's 4,000 for the machine. And small, looks kind of like a popcorn machine. It's that
That's a
tiny.
lot cheaper than I thought, guessed.
Yeah. This one costs a lot more than that.
Yeah.
But I got this about 5 years ago, so it's sort of, how it goes with technology, right? It gets cheaper.
10 years there'll be one in every home.
Well, then you buy it at Staples or
Yeah.
something like that, right? Yeah.
I'm hoping so, yeah.
Yeah.
Well, technically you can buy the inexpensive ones, like the $2,000 ones, which are they're not fully encased like this. So what's is there an advantage of a fully encased one over top of one that's not, or is it just
Well, it's the type of printer it is. Like this one, because it works with the UV light, it's got to be enclosed because it's kind of bad for your eyes to be shooting out at you. Plus, even sunlight would affect the build while it was working, right? So any goo that kind of spills out and gets left out, it eventually sort of hardens on its own just from residual light bouncing around your house. So it's kind of got to be dark in there. That's how this one works. But there's other 3D printers that work different ways, and a lot of the ones that are inexpensive that a lot of people are pretty excited about, sort of the hobby style ones, is they work with an extruding nozzle. So they'll have a little nozzle that heats up. And you have a long filament of plastic, just on a big spool. You just sort of feed it in, and it sucks up the plastic, heats it up, and then squirts out little tiny, tiny droplets of this plastic, layer by layer by layer. So they work a little slower than this one, because this one does the layer all at once. They also don't have some of the detail capabilities that this one is, because your resolution is as fine as you can squeeze out a little glob of goop. And plus those ones too, they don't... you have to build your objects self-supporting because they don't have like a support material for them. But a lot of that stuff you can kind of work around, and they're a lot of fun to play with. They're great for learning, getting into it, hobby stuff, and especially kids and stuff at like libraries and these kinds of things. I think this technology as a technology is something we should probably all be very interested in, because it's different applications are being developed all the time. Different machines that print metal, that print concrete. There's ones that some people are working on some that actually build houses. So they're big enough, they're on like tracks, and they kind of move and they squeeze out concrete and basically can build a house of any shape. They're kind of ugly at this point because it's really, it's very basic, trial sort of stuff. But imagine, I don't think it'll be too far before maybe ships are built that way, with giant machines instead of a dry dock, instead of welders going in and hammering it. You may have robots basically going around and 3D printing the whole hull of a ship, while it's being built. Airplane parts, a lot of that stuff's being done already for cars and things like that. Because it's very easy to change. You don't have to go and have everything retooled. You don't have to have new molds and dies cut for your new parts to cast in plastic or injection molding or anything like that. You just have to change the computer file and then send the computer file to the same machine you always do, and it'll make another version of your piece. So, I mean, the balance is that they're more expensive to operate, and they're better for sort of one-off things, and mass production is still pretty cheap. So
We're still early in that technology. It's like that.
That's right.
It's just like your inkjet printer. I mean, 20 years ago, it was like ridiculous to have one in your house, and then now it's so it's a.
Yeah, and I think if there's anything that people can kind of be learning to get on this technology, it's the stuff on the computer. It's how to build things and do 3D models on the computer. And if your kids are interested in that stuff, just get them into it, because those are the people who are going to be having the jobs, because the robots will be doing the work, right? Yeah. So it's a great. If you can design stuff, you can in the right format, you can make pretty much anything. So. I use it to build, for fun stuff. I've used my 3D printer because I like little spaceships, and I'm a bit of a nerd, and I play games with spaceships and go pew, 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 and that kind of stuff. This one is one I designed and just 3D printed. on this machine here, right? Some of these are, a lot of these are ones I've purchased just from kits or whatever, and just kind of glue them together and paint them. It's sort of a hobby of mine, little soldiers and stuff like that. But once I sort of discovered, well, I've got a 3D printer, I've been paying a lot of money for these things, you know, why don't I build one that I really like and, you know, make my own kind of thing? And it's just sort of the tip of the iceberg of what you can do. Like you could even make, yeah, you could even make parts for your own car if you know what you need. You don't have to go to the store to buy a replacement part. You know, you could have a little gasket made on your machine at home or something like that. It's gonna, yeah. It'll take a while, but it'll be a different world when you can do that.
I toured the Haley plant where they make aircraft engine parts.
Yeah.
It's Magellan now, but some of those castings they do, they're subjected to 100 X-rays before they're finished with them.
Oh yeah,
Make
yeah,
sure
yeah.
that they're proper, you know. Cause
Hour and a half, and then I just stick another plate in, and stick another plate in. And while these were, while one was running, I'd wash and clean the other ones. So we'll talk more about the 3D printer inside where you can see it. I keep it in there because it's very sensitive to temperature.